All right, week 2, June 29th to July 5th, new 16, last piece of the elimination systems work that we're doing, and we're getting down to it. We are almost done with the new week 2 material. You guys are almost there. So let's get started. All right, solving by elimination, and we're stating that ordered pair solution. So we talked about what it takes to solve a system by elimination, and we also saw what they look like when they're already ready to solve by elimination. We looked at what it takes to solve one that you needed to multiply one of them by multiplication to get it ready to solve by elimination. When we look at something like this, it doesn't look ready because, the signs are not set up, and it doesn't look like any of the numbers are set up either. So if we kind of highlight this and get it ready, or even try to look for what is ready, it doesn't look like much because we have the x's, we have 2 and 5, we have the y's, we have 3 and 4. The numbers don't really count because there's nothing to eliminate there. We talked about what makes it look ready, or what makes it a good fit. 1 we can turn into any number by multiplication because 1 times any number is that number. There's a trick that allows you to turn any number into another number, and that's what we're going to use here. So really, the one thing you want to focus on is the signs, because once you decide and use this trick, you're going to be golden. So looking at the signs, like you could be somebody who says, I'm going to eliminate the x's every time. And you could use that. You could say, I'm going to eliminate the y's every time. And you could use that. You could be somebody who decides each problem. You could alternate, and that works. You could base it on the signs, and that's okay too. For this one, it really doesn't matter because the signs are all positive. So you're going to have to also use the sign trick. So remember, if you need to switch one of the signs, you have to pull in the negative. You only want to use the negative on one of the equations because we only need to change the sign on one of the equations. So again, I usually use it on the smaller equation because I like to keep as much as I can positive. So what I'm going to do is I'm going to pick which I want to eliminate. So for me, I want the x's to eliminate. So I'm going to put an arrow over what I want to eliminate. So I want the x's to eliminate. All right. So since I want the x's to eliminate, I'm going to multiply both equations. Okay. And what I do then is I'm going to switch the coefficients. So see how this has a 2 on it? I'm going to multiply the bottom one then by a 2. And see how this has a 5 on it? I'm going to multiply the top one by a 5. Now, see how they're both positive? They both don't have a sign. I need to make one of them positive. So I'm going to multiply the bottom one by a negative. Now, you could have multiplied the top one by a negative. The reason I multiplied the bottom one by a negative was because this big negative 34 here. But again, it's really up to you. So I'm going to do this. I'm going to multiply this, this, and this. So I get over here 10x plus 15y equals negative 40. And then on the bottom, I'm going to get negative 10x minus 8y equals positive 68. Okay, again highlighting. Here's my red. Here's my blue. Here's my green. These zero out. Here I get 7y. Here I get 28. Divide both sides by 7. I get y equals 4. Everything is the same after this first step, going across. Actually, after that step, right? I get the 4 here. Okay, I'm going to plug it into that first one. So I get 2x plus 3 times 4 equals negative 8. So I get 2x plus 12 equals negative 8. I subtract the 12. I get 2x equals negative 20. Divides both sides by 2. I get x equals negative 10. So I get negative 10, comma, 4. And I'm done. Excuse me. Let's look at number 2. All right. So I have 2, 6, 3, 7. Oh, there's a mistake in this one, and I didn't catch it. Right now, make this a y. In order for any of these problems to work, you have to have, obviously, variables that line up. So this was just, there was a typo. So make sure that that has to be a y in order for this to work. All right, so since we had the x's cancel out last time, let's do the y's just so that you can see the difference. All right, let's do the y's that'll cancel out this time. All right, so I'm going to highlight. Here's my x's. Here's my y's. Here's my numbers. All right, so notice that because my signs are equal, I definitely have to have a negative. Oh, shoot. Sorry. All right, I definitely have to multiply by a negative. I'll do my negative on top this time. Remember, it does not matter. I can only do the negative in one place. Okay, since the 3 is here, I'm going to multiply the 3 on the bottom. Since the 7 is here, I'm going to multiply the 7 on top. So let's see what we get. I'm going to distribute this out. I'm going to get negative 14x minus 21y equals negative 42. On the bottom, distribute this out. I get 18x plus 21y equals, don't have my calculator with me. Make sure you check my work. I think it's 78. Yeah. All right. So now, again, highlighting. Just to keep all my columns in check. Okay. Rats. All right, 18x and minus 14x gives me 4x. Those zero out. 78 minus 42. I get 36. Divide both sides by 4. I get x equals 9. Placing it in my ordered pairs. I get 9 here. If I'm plugging it in, I'm going to plug it into this first one. So I get 2 times 9 plus 3y equals 6. I get 18 plus 3y equals 6. Subtract the 18 from both sides. I get 3y equals negative 12. Divide both sides by 3. I get y equals negative 4. So my ordered pair is 9, comma, negative 4. All right, let's look at number 3. All right, highlighting the columns. X, Y numbers. Looking at this one strategically, I want to cancel out the Y's. Excuse me. And the reason why I want to do this one strategically is because I already have my opposite signs. So I don't have to mess with that. They're already opposite, so when I multiply, all I have to worry about is the numbers. So I can multiply the bottom one by 3 and the top one by 5. Notice how I always switch. Okay, my numbers always get switched. So if my top coefficient is 3, I multiply the bottom one by 3. If the bottom coefficient is 5, I multiply the top equation by 5. The signs are never part of the multiplication. The way the signs come into play is if they're opposite, I'm good to go. If they're the same, I need to multiply one of the equations by a negative. Because in the end, I need to have those opposite signs. So when I do this, I distribute that 5 out and I get 20x plus 15y equals 5. On the bottom, I get 6x minus 15y equals, this is another odd one, I don't know off the top of my head. It's definitely going to be a negative. Don't have to worry about that. 57. All right. Now looking at this, I have my columns. I already know I'm good to go with the elimination piece because I have my matching numbers, opposite signs, so those zero out, and then 20x and 6x is 26x. Negative 57 plus 5 is negative 52. I divide both sides by 26, and I get x equals negative 2. Place that in my ordered pair, and then plug in, I'm going to do my first equation. So 4 times negative 2 plus 3y equals 1. So I get negative 8 plus 3y equals 1. I add 8 to both sides. I get 3y equals 9. I divide both sides by 3, and I get y equals 3. So my ordered pair is negative 2, comma 3, and I'm finished with this one. Last one. Lining up my columns, I have the red, the blue, the green, and I'm going to cancel out my x's just because I have those opposite signs already. Because of that, I only have to worry about my numbers. So because 5 is on top, I'm going to multiply the bottom equation by 5, and because 11 is on the bottom, I'm going to multiply the top equation by 11. I don't have to worry about the signs because I already have opposite signs. I'm going to distribute that 11 out, so I'm going to have negative 55x, whew, these are getting big, plus 44y equals, lordy, I do not have my calculator right in front of me. And contrary to popular belief, I don't have this one memorized. 13 times 11. It's definitely going to be a negative. 143. All right, bottom one. 55x plus 30y equals negative 5. Lining up, column by column. And sometimes these don't look like they're going to work out nicely, but then you're surprised. All right, the negative 55x and the 55x zero out. We end up with, sorry, it's jumping all over the place, 74y equals negative 147. Yikes. This one does not come out to be a nice number, unless we messed up somewhere. Just double checking my work. Now, when we get something that is not a nice number, we want to check our work, because ultimately we could totally have something that is not a nice number, but a lot of times the answers won't be totally not nice numbers. Like, they're not going to be really ugly numbers for us. So, we take a step back and we look at things. Now, I took a step back, I looked at it, and I've been doing math all day, and I know myself, and when I've been doing math all day, I tend to, like, my brain just gets tired. Plus, it's summer, I'm a little out of practice, and I noticed that 5 plus 3 does not equal 7. Okay, also, I know that, like, when I'm looking 74 and 74, that's, doubling 74 is, double 7 is 14, double 4 is 8. So when I divided 174 divided by when I can't even talk right now. When I divide 170, oh my gosh. There's also a bunch of numbers right there that are all very similar. So if you ever have trouble with transposing numbers, switching numbers, this also gets you. When you divide 147 divided by 74, you get like 1.98, and it's so close to 2. That is really, 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 really close to 2. Obviously, 173, oh my God, I should really just give up now on this problem. 143 plus 5, which is essentially the same thing as negative 143 minus another 5, is negative 148, not negative 147. So then when I divide by 74 on both sides, I'm going to get y equals negative 2. When I put that in my ordered pair, I get negative 2 here. And then when I plug that back in, I'm definitely plugging in to, I don't know, they're both not really great. I'll do the second one. 11x plus 6 times negative 2 equals negative 1. 11x minus 12 equals negative 1. Plus 12 equals 11x equals 11 divided by 11, x equals 1. So 1. My ordered pair is, and thank goodness, this worksheet is done. Almost didn't make it. And that's probably when you should step away from the math. That's another thing too. Usually you won't have a completely rotten decimal answer for a problem that is all really nice integers, whole numbers like this one. If you have fractions, if you have decimals in your starting problem, then more than likely, yeah, you'll have decimal answers and stuff. But kind of, what you give is what you get, that kind of thing. What you start with is going to be kind of where you go with your answers. If you're getting a really rotten answer for a relatively nice question, more than likely you may have taken a wrong turn somewhere in your math. All right, so it's been real. I can't say it's been real fun, for at least for number 4. I will see you guys soon. All right, bye.